Why is the double-slit experiment called the most terrifying physics experiment in the world? In the 17th century, Dutch scientist Christian Huygens first proposed the wave theory of light. He believed that light propagates like water waves, and when two beams of light meet, they interfere, forming a pattern of alternating bright and dark fringes. However, Newton's corpuscular theory, backed by his authority in the physics world, became the dominant view in the 18th century. Thomas Young successfully vindicated the wave theory with his double-slit experiment. He passed a beam of light through two narrow slits in a barrier. If light were particles, two distinct bright bands should appear on the screen. If light were a wave, it would create an interference pattern of zebra-like stripes. The experimental result was just as Young predicted. The appearance of interference fringes declared the victory of the wave theory. This shattered the existing understanding of light. In the early 20th century, the rise of quantum mechanics began to reveal the strange nature of the double-slit experiment. Scientists upgraded the experiment to a single photon emission mode, firing only one photon at a time. In theory, a photon can only pass through one of the slits and cannot interfere with other photons, so two bright bands should appear on the screen. However, the result was unexpected. As the number of photons accumulated, an interference pattern appeared on the screen once again. What was a single photon interfering with? This question became a perplexing puzzle for physicists. To solve the mystery, scientists placed a detector in front of the slits to observe the photon's path. However, an even stranger phenomenon occurred. When the detector was turned on, the interference pattern on the screen vanished, leaving only two bright bands. And when the detector was turned off, the fringes miraculously reappeared. It was as if the photon had consciousness, able to sense whether it was being observed and switch between its wave and particle states accordingly. This discovery completely shocked the scientific community. The act of observation itself changed the experimental outcome. The behavior of a microscopic particle is no longer independent of the observer. To explain this phenomenon, Einstein proposed the light quantum hypothesis, revealing that light has wave-particle duality. It is both a wave and a particle. Its state depends on the act of observation.